Hello everybody and welcome back. Root Beer here. We're going to be continuing on our look at the 2011 Galois contest put out by the University of Waterloo. We're on to question number 2, so if you're looking for the start of the competition, that was the previous video. So I'm sure you can find a sort of, YouTube has a side link recommended video thing. I'm sure it's in there. But we're taking a look at question number 2, and let's take a look at what question 2 says. So, Aaliyah has a bucket of coins. Each coin has a 0 on one side and an integer greater than 0 on the other side. She randomly draws 3 coins, tosses them, and calculates the score by adding the 3 numbers that appear. Okay. So we have an A, B, C part. Do we have a D? Nope. Alright, so just need to get through these and write up and explain what we're doing at each step. On Monday, Aaliyah draws coins with a 7, a 7, a 5, and a 10. When she tosses them, they show 7, 0, and 10 for a score of 17. So they're continuing to try and explain how this process works, just to make sure we get it. That's nice. What other scores could she obtain by tossing these same 3 coins? Okay. So each one of the coins will land either heads with the number or tails with a 0 on it. Okay? But each coin has a different head. It's like flipping a penny, a quarter, and a dime. So we would get different sums that way. So really, the best thing to do is we've got 3 coins here. We should take a look at each of the possibilities of which possible coin flips come up. Okay. So let's write out some possibilities. So we're going to figure out each of the possible coin flips, like the 5 turned up 5 and then we had 2 zeros, that sort of thing. And then we're going to figure out the corresponding sums. And that will tell us exactly what we need to know in the question, which is what other scores could she obtain by tossing those same 3 coins. Now each coin, then this is just to help guide us. Each coin has 2 sides. Did they say equally likely, or am I putting words in their mouth? They don't say equally likely, but I guess we're not doing any probability here. So we have 2 sides that could come up. So we have 2 sides that could come up for the first coin. We could have a 0 or a 5. We have 2 sides that could come up for the second coin. That's a 0 or a 7. I'm just putting them in numerical order. And our third coin has 2 sides, 0, 10. And if we want the total number of combinations we could have, well, since they're independent, what we do is we multiply them together. So there's going to be 8 possible ways for the coins to land. Okay, now I calculate this 8 not only to illustrate to you, how we do these calculations, 2 sides each, and there's 3 coins, so we multiply them together, but to help guide me as I write down all these possibilities. So I should get 8 different ways that the coins can land, heads or tails, that sort of thing. And if when I'm doing my calculation I get more than 8, I need to stop and re-examine, have I made my calculation wrong, or have I, miscounted, or have I, double counted something? And if I'm determining all the flips, if I'm not doing them in a particular order, which I will do them in a nice clean order to show you how to do that. But if I wasn't doing them in an order, I would know I'm finished by the time I get 8 of them. Okay, I'm looking for 8 different coin flips. That's the way the math works out. It's the fundamental principle of counting that we're using here. So if you have independent activities, to get the total number of combinations, you multiply them all together. So I'm going to start listing out possibilities, and I'll know I'm done when I get 8. It'll be a nice little confirmation here. So what I'm going to do is I'm going to make a nice little chart. I'm going to say the first coin, the second coin, and the third coin. So the first coin could either be a 0 or a 5. I'm going to put in a whole bunch of zeros here. The second coin could either be a 0 or a 7. And the third coin could either be a 0 or a 10. So you'll notice I'm writing these out in a very, very methodical way. If you're unfamiliar with exactly how I'm writing these out, I encourage you to go look up binary numbers. It's something you possibly have seen at this point in your education, but I'm not going to guarantee you've seen it. But we say, well, we're just going to let the first coin be 0 for a while, and then the second coin be 0, and the third coin be 0, and then, well, what happens if we keep the other two 0, but then flip the 10? And then, well, we've run out of all possibilities where we're going to have the first one 0 and the second one 0. So then we'll have the first one 0 and the second one flipped, and then the third can go back to 0, that sort of thing. So let's figure out these sums. So 0 plus 0 plus 0 is 0. Here we have 10. 7, 17, that's the one that we were talking about. That's the one they gave us. 5, 15, 12, and then 5 plus 7 is 12, plus 10 is 22. So we want the other scores. So I'll make a little statement here. So excluding the 17 that Aaliyah, I think was her name, got, she could have had 0, 5, 7, 10, 12, 15, and 22. So you notice that 0, 5, 7, 10, 12, 15, 22, and the original 17, that's 8 different possibilities. And we just double check if we go back a page. We had 8 different flipping combinations, just as we predicted. So we knew we have exhausted the total possible list of numbers that she could have had. Okay. So our nice little therefore statement includes the 17 that she had and highlights the 7 other possibilities that she could have had. It's interesting that there were no repeats. Very interesting. All right. So B. On Tuesday, Aaliyah draws 3 coins and tosses them 3 times, obtaining scores of 60, 110, and 130. On each of the tosses, exactly one of the coins shows a 0. Determine the maximum possible score that can be obtained by tossing these 3 coins. Okay. Well, I don't know what the values on these coins are, so what I'm going to do is I'm going to give them names. I'm going to say the first coin has 0 or A on it. The second coin has 0 or B on it. So the first coin will have a 0 or A. You don't have to use A. You could use X, Y, and Z. You could use capitals. Doesn't really matter. The point is, we just have these nice stand-ins. These are the variables. We don't know exactly what they are. And we have to be very particular. We're not asked to figure out A, B, or C. Let's reread the question. Determine the maximum possible score. Well, the best possible score, and we're going to make a note of this because we should be explaining what we're doing in our reasoning. The best possible score is going to be obtained when we have no zeros. So the maximum score is given when no zeros flip up. So we must determine A plus B plus C. Now, if we figure out A, B, and C individually on the way to this, that's fine. But I suspect there might not be enough information to exactly figure them out. Well, let's find out. So we're told that we have possible flips. So A, B, and 0, because that's a flip with exactly 1, 0. A, 0, and C, that's a flip with exactly 1, 0, exactly as we wanted, and 0, B, and C. Okay? You can try and work out other ones, but these are the only ones that have exactly 1, 0 in their flip. And we're told some sums here are 60, 110, and 130. We're just going to double check, make sure we got those right. 60, 110, and 130. Okay? Now, for those of you who aren't as familiar with variables, you might be saying, well, how do you know A plus B is 60? Why couldn't A plus B be 110? And the point is, it doesn't matter. It really doesn't. We're just saying, okay, A plus B, that's the one that's going to be 60. A plus C, that's going to be the one that's 110. There is nothing to really tell these coins apart, other than one has the variable A, one has the variable B, and one has the variable C. Okay? There's no way to tell whether or not A is supposed to be greater than C or anything. We're not given any information like that. So this is just a choice. Okay? If we wanted to, we could say, oh, the two coins that give the sum of 60, we're going to say that that one has the A and that one has the B. Because they're just variable names. They don't really matter yet. Okay? But now once we've made this assignment, once we've said A plus B is 60, now we've sort of locked in what A and B might be. Okay? So I didn't know that A plus B was 60. I just said, well, A plus B, we're going to let A and B be the variables that give me the 60. There's no way to tell these coins apart. All right. So I want A plus B plus C. If I can figure out A, B, and C, that's great. If I can't, that's all right. Now, I keep alluding to the fact that maybe we can't, or maybe that's not necessary. And that's because I've seen a lot of questions like this throughout the years. So I have a sort of an instinct as to what to do. I have 3 equations. Each of them uses an A once, and we use the B once. A is used twice, B is used twice, C is used twice. My instinct is to add them up. Okay, so I'll get 2 A's plus 2 B's. We just add the equations. Plus 2 C's, and then we have to add up over here. So that's 60 plus 110 plus 130, and that's going to give me a total of 300. But look at this left-hand side. I can take out a factor of 2 here, and I'll have 2A plus B plus C is 300. Well, A plus B plus C, that's exactly the maximum score that I'm trying to determine. So if I want just A plus B plus C, I need to divide both sides by 2, and I'll get a total answer of 150. Okay? So that's going to be my maximum score. I could make a little statement about that. And you'll notice we don't know what A, B, and C individually are. But we were able to get our answer of 150. Now, if you didn't have sort of the foresight to realize, oh, we need to find A plus B plus C, and you wanted to just figure out A, B, and C and then determine the max possible score by figuring out all the combinations, that's fine too. If you just have this A plus B plus C is 150, we can actually get each of the other numbers, and I'll show you how. So this is a little sidebar here. We'll go back to the actual question up here. If I know A plus B plus C is 150, and I want to figure out A, well, I know that 0 plus B plus C was 130, so I can subtract these. A minus 0 is, of course, A, B minus B is 0, and C minus C is 0. 150 minus 130 is 20, so A is going to be 20. And we can do the exact same thing and figure out what B is. B is going to be 150 minus 110, so B is going to be 40. And you can already see 20 plus 40, well, that's 60. And we were told A plus B plus Z is A plus B plus 0 is 60. So wouldn't you know, we've been able to verify that. And our last one, C, well, that'll be 150 minus 60, so that'll be 90. And so now, if we wanted to, we could write out 8 possible combinations and figure out the maximum. And you'd realize pretty quickly the maximum is just going to be the A plus B plus C value, which we can remember is 150. Or we could just sit down and calculate outright. Either or. Either way is fine. Either you do a little legwork ahead of time, realize that you need A plus B plus C as your final answer, or you can go ahead and work out A, B, and C, and then mess around until you find the maximum score. Alright, so C, which is the last part in question number 2. On Wednesday, Aaliyah draws 1 coin with a 25 and 1 coin with a 50, and a 3rd coin. She tosses these 3 coins and obtains a score of 170. Determine all possible numbers, other than 0, that could be on the 3rd coin. So again, we don't know the value of this 3rd coin, so what I'm going to do is I'm going to give it a variable name. I'm going to call it X. You might want to call it D, because we had A, B, and C already. But brand new question, I'm going to call it X. So let X be the non-zero value of the 3rd coin. Okay. Now, we could be smart about this and realize, well, if she flips the coins and obtains a 170, the 25 and the 50 are not enough on their own. They would give a total of 75. So they wouldn't be enough to get this 170. So no matter what happens, she had to flip the 3rd coin X side up. Now, we could point that out. Or another thing we could do is just, well, we've got 3 coins again. We know we're going to have 8 possible ways to flip them up. So 3 coins implies 8 ways to flip up. So we could just work out each one and work out the potential sums here. And compare these sums to 170. I think that's the way I'm going to handle it. So the first coin could be 0, the second coin could be 0, and the 3rd coin could flip up and be X. That way the sum will be X, and we need to have X is equal to 170. Oh, sorry, the 3rd coin, I guess, could flip up 0. And then we need to have 0 is equal to 170. Well, that's just ridiculous. So we could have 0, 0, x, giving us the sum of x. And so we need x is equal to 170. We could have 0. Now we've had the second coin be 0 this entire time, but there's nothing left to do with the second coin being 0 and the first coin being 0. So we went through the other two possibilities. So we'd have a 50, and we could have a 0, and that would be a sum of 50. And we'd need 50 is equal to 170. That is just silly. That doesn't make any sense. Or we could have 0, 50, and x, and so we'd have 50 plus x is equal to 170. That's certainly possible. We could work out what x might need to be from here. So now let's get into, we'll have 25 for the rest of this. And we just sort of copy the list we already had, 0, 0, 50, 50, 0x, 0x. So our sum here is 25. We need 25 equal to 170. No way that's happening. Here we have 25 plus x. That could be 170. 25 plus 50 plus 0, that's going to be 75. That is never going to be giving us a final answer of 170. And remember, we were told that Aaliyah flipped over 170. And finally, 25 plus 50 is 75, plus x equals 170. We can get the values of x by finding solutions to the equations we were given. So x equals 170. Well, that's just x equals 170. 50 plus x equals 170. Doesn't take too long. I'm sure you can rearrange that to get x equals 120. 25 plus x is equal to 170. And that can also be rearranged to give you x is equal to 145. And the last one that we just worked out, 75 plus x is 170. So x should be, I think it's 95, but I'll just double check because why not? We have our calculators. We should certainly be able to use them. So x is 95. 120, 145, or 170. I think that's all we were asked for, but let's just double check. Determine all possible numbers other than 0 that could be on the third coin. There we go. So that concludes question number 2, part C, and that is question 2 in its entirety. So join me in the very next video where we're going to tackle question number 3 on the 2011 Galois paper. Thank you guys so much for watching, and as always, I'll see you next time.